Hello and welcome to the AWS Summit Online. My name is Blair Layton and I'm the head of the database business in the Asia Pacific and Japan region for our public sector customers. Today we're going to be talking about purpose-built databases for building modern applications. What we're going to go through is looking at what is a modern application. So we'll give you an idea of what we define that as. And then we're going to go through and look at why customers should be considering purpose-built databases, and then looking at all the different AWS databases that can help you build these modern applications. At the end of this presentation, that should give you a really good idea of if you're going to build a new modern application, what database or databases you can use to build for those applications. So what is a modern application? Well, first of all, let's talk about a traditional application. If you think what we've been using for the last 20 years or so, it's basically a two-tier or three-tier application where you have a client connecting either to a web or application server, and then that connects to the database. Or if you're still using client server, it's simply a client connecting to a database. Now, for modern applications, what we're seeing is that there's a lot of different requirements. So you're going to see that if you're building something that's hopefully going to be very successful and it's either a mobile application or online, you could have millions of users. You also could have terabytes or petabytes of data associated with that application. It could be application logs that are just generating lots and lots of data with all of the users, or it could be a combination of those logs as well as things like video, audio, and picture files that are taking up lots and lots of data. Then if you look at locality, we're going to look at deploying globally. Let's say you have a customer today whose business is built in the USA, or someone else who's built their business in Australia, and they want to expand into Europe. They're going to have to look at the architecture of that application to make sure that it can perform, and to the next point, have enough performance and latency to make sure the customer experience is good as they expand across the globe. And then you're looking at the number of requests. So if you've got a very successful application and that's going to have millions of users using it, then you're going to have a very consistent high rate of requests coming in. But let's say you've got a smaller application, but it could be very bursty. Let's say something like a learning management system where students are going to come into that system, especially at enrollment time, as well as at exam time. And then of course the normal daily business of coming in the morning, looking at their classes, and then at the end of the day, logging off. So you've got different types of profiles where you could have bursty or sustained high levels of input from users causing millions of requests. And then looking at the different access, traditionally it's probably just been a computer or browser that's been accessing your applications. Now, of course, you've got mobile, and it's often mobile first when you're looking at building a modern application, but you've also got to take into account things like IoT, and then even devices that we haven't even thought of yet that are connecting into your applications. And then scale. We want to be able to just scale this up really quickly. Again, coming back to that LMS or learning management system, you don't really know when it comes to enrollment time how many students are going to come in and enroll in your particular course. So you need to be able to scale that out, and especially if it's going to be global, to be able to provision those resources in multiple places across the world without having to worry about resource constraints. And then we want to be able to pay as you go. So let's say that, again, you've got all the students, they've come in for their enrollment, and then everything quietens down. We don't want to keep paying for all of those resources, so we want to be able to turn off the resources and then only pay for what you actually need. Now, if we're going to look at it from a development perspective, we want to be able to have APIs and be able to separate the application components and the storage, especially when it comes to the database. So we want to be able to have compute and storage in different tiers. Now, looking at Amazon and Prime Day, this is a good example of a massive event internally where we have to scale and have lots of users coming in over a single event. Now, across all Amazon's 442 fulfillment centers, we have a huge amount of data that needs to be processed. And that's across 48 hours going around the world for all the different cities and countries of Prime Day. Now, these sources made 7.11 trillion calls to the DynamoDB API over that period, peaking at 45.4 million requests per second. Amazon Aurora also supports a network of Amazon fulfillment centers with over 1,900 instances of Aurora Postgres with 148 billion transactions, and they stored 609 terabytes of data and transferred over 306 terabytes of data for Amazon Prime Day. So that's an example of a modern application and the scale that you could actually achieve and have to manage. So we want to build things with purpose. And if we go back and look at the different types of use cases that you have, you probably don't need to have one database that is going to do everything for you. It is probably better to use something that is specific for the task at hand. So here you can see different types of vehicles that are purpose-built for their job. And that's what we're asking you to consider when you're building your modern applications, just like with Prime Day at Amazon.com, where we use DynamoDB and Aurora Postgres for different use cases to help serve our customers. So instead of building a monolithic application, perhaps you should start considering building microservices. So if we look at the way that most customers have built their applications, then they're going to have all of their code in this one monolithic executable. Now, some customers did start splitting up applications and they have gone down the SOA route. And that's kind of like the first step. The problems with SOA or service-oriented architecture is that you typically need an enterprise service bus to orchestrate all of the different components, and it still became quite complicated. Well, the way we're looking with microservices is you break those components up into specific services which even have a purpose-built function for that individual service. And behind that service, you're going to choose the right technology for the code that you're going to write, and it could be a particular language, let's say it's .NET or Java, or it could be a combination of those together with the databases that you need to support that specific service. And that team has the full control over that technology that they build that with. Now, the thing that is different with SOA and microservices is that with microservices, you're going to be calling everything with APIs over HTTP. So it's much more loosely coupled and doesn't need something like an enterprise service bus to hang it all together. So why would you consider purpose-built databases for this modern application design with microservices? Well, traditionally, you've had a relational database from the 1970s when COD first defined that model, all the way up until now. The great majority of databases that are out there are relational databases. But around the 2000s, when the internet started becoming popular and we had the dot-com boom, people started to realize, including Amazon, that there was problems with scaling these relational databases to fit all of the needs for these modern applications. And that's where we developed the Dynamo technology and released a paper in 2007, and that became DynamoDB in 2012. So what you've seen there is that we just created a purpose-built database to solve a particular problem there. And from that period, we also had other databases such as Cassandra, React, we had CouchDB, MongoDB, and all different flavors of NoSQL or new type of databases that came out. So now there's a lot more choice for you when you go and build modern database architectures to choose from all these different databases. And there are many, many out there. In fact, there are hundreds. So there is a good choice for you to go and look at for these modern applications. So if we're looking at why you want to build these purpose-built databases and why do you want to use them, again, it comes down to the scale, performance, and availability for the specific task. So if you think of that good old relational database that you threw everything at before, maybe it supports JSON now, that's great. But if you used a specific database that was able to handle JSON documents and manipulate them well, I'm sure you're going to get better scale, performance, and availability for that particular solution rather than trying to get the relational database to do everything. So Capital One is another customer who has adopted this purpose-built database technology. So they use Amazon RDS or Relational Database Service for their transactional state management applications. And then when they want to look at analytics for their web logs, then they're putting that data into Amazon Redshift where they have to do groupings of those web logs and then do reporting on them. And then looking at consistent low latency, Amazon DynamoDB for the user data and the mobile app is going to be what they use there. So again, that's another customer, just like Amazon with the Prime Day. Capital One has got their own specific requirements and have used different databases for those specific use cases. So what we really want you to do is to look at the use case and choose the right technology. So to help you with that, we have defined a number of different categories. So here you can see that there is good old relational as the first one. Then we've got key value, document, in-memory, graph, time series, ledger, and wide column. And at AWS, we have a series of different databases that match each of these types of technology. And what we're going to do now is we're going to go through each of these different types of technologies to give you a quick overview to help you understand what each one is all about. So, Amazon Aurora. It is a MySQL or Postgres compatible relational database built for the cloud. So this is something that we re-architected for the cloud using our own AWS services, and we built a very specific technology for the storage tier, which is storing your data based on the database logs. So it's not actually using a file system for the writes. It is writing the database log changes into the storage service, but then the reads are reading off a file system. So this is a very different way of using this technology. So not only is that storage service very different in the architecture, the way that we store the data is across 3 different data centers or availability zones with 2 copies in each of those facilities. So 6 copies of your data for very high durability and resilience. From a performance and scalability perspective, you're able to actually get up to 5 times more throughput for Aurora MySQL and up to 3 times with Aurora Postgres. Now, it should be stressed, this is not running a single query like you can run on your laptop and it's super fast, and then you put it on Aurora and you want to go say, hang on, it's not as fast as my laptop. We're talking about running hundreds of thousands of different transactions through our Aurora technology to give you that throughput that you simply would not be able to do on a normal instance on AWS without this specific technology. So if we're looking at security, of course, at AWS, security is a day zero priority for us. So you're going to have security in transit and security at rest, and all your backups will be encrypted as well. And then, of course, it is part of the RDS managed family, where you're going to get all the things like provisioning, patching, upgrades, and backups, and so on, all managed for you as well. So what I want to do now is to give you an actual demo of how Aurora works. And then after that, we'll come back and start talking about some of the other database services at AWS. Welcome to the demo. Here is the RDS console. And on here, you can see that we have 2 databases running already. And what I'm going to do is quickly create another database and show you how easy it is to get started. So there is the standard create option as well as the easy create option. We're going to use the easy create option and then look at an Amazon Aurora database for MySQL 5.6 compatibility, and we'll create a dev test instance. It's got a reasonable size server for that. You need to enter the details for the cluster identifier, so we're just going to put a custom name in there, and then you could change the master username if you want. And there's an auto-generate option for a password, but if you want to put it in, you just unclick that, and then you can put the details in there. I'm going to stick with the automatic one. So click on Create Database, and then that's going to take us to the screen where we can see all of the databases that are currently running. So this is the cluster that's being created, and then there's some information at the top to tell you what's happening as that's getting created. Now you'll see there's another series of databases and clusters here, and this is part of a global database. So this is running Aurora Postgres, and this particular database here has got a writer and a reader, and that's in the Oregon region, and you can see across different AZs. And you can see my console here is in Oregon. Now, the interesting part here is this other cluster has got a reader node in it that is in the Singapore region. So what we've done is created a global database connected between Oregon and Singapore. And if we click on that, that will open the Singapore console. So you can see AP Southeast 1 here, so that's for Singapore. And if I go back and show you, then this one is the Oregon console here. So let's have a look at this Singapore cluster. We've got the existing details above, and then we want to check the monitoring. Now, what we really want to look at here is what is the time it's taking for the data to propagate from Oregon to Singapore. So this is the one you want to look at, DB replication lag in milliseconds. We'll click on that so you can see clearer. And you can see it's roughly about 125 milliseconds latency on average to bring that data from Oregon to Singapore. So that's giving you the capability to read the data in Singapore for your application users there, as well as give you a disaster recovery option in case something happens in Oregon. So we'll close that down and then close the Singapore tab as well and go back to the Oregon console. So you can see now the database has been created, so you need to gather the password details from there for this particular cluster. And you can see the writer is now being created. So the cluster is done, but then the writer node is getting created. So hopefully that's given you an overview of how to quickly create an Amazon Aurora MySQL database, as well as how we actually build out global databases and the capabilities that we have with Aurora, Postgres, and MySQL for that matter. Thank you. Well, hopefully that demo has given you a good overview of Amazon Aurora, and it probably has given you a good introduction in terms of how you access our database services through the AWS console. Now I'm going to move on to our other database services, and the first one I want to talk about is Amazon DynamoDB. Now remember, I referenced Amazon DynamoDB with Amazon and Prime Day, as well as with Capital One. So customers out there are absolutely depending on this for business critical applications. And at AWS and Amazon, it is really critical for all of the infrastructure that we run. Many of our services depend on DynamoDB to make sure that they're running themselves. So you can trust that this is a super reliable database. And not only that, it does scale and perform very well. So you can start with a very minimal throughput requirement, and then if your application becomes successful, you can increase that throughput, or we have auto scaling capability where you can actually have DynamoDB provision extra throughput depending on the requests that are coming through. Now, as you're changing the request level, let's say your database is getting busier and busier and we need to increase the throughput, then the response time is always going to be single-digit millisecond. And I've seen this with some demonstrations that we've done where we've actually doubled the capacity and then doubled it again and then reduced it afterwards, and the response time is consistent throughout that process. That is very, very hard to do with a traditional relational database. So you'll see this as something that is very compelling to start off with if you're building a new modern application. Now it is a serverless architecture, so you don't have to worry about managing servers or EC2 instances, and it also allows you to provision throughput on each individual table. The security that is in place now is much improved. So remember, DynamoDB has been around since 2012. So if you looked at this a couple of years ago, there's a number of different features that have been introduced, including improved security, as well as capabilities around things like time to live. And the last one there on the slide, global data access. Now what we have is DynamoDB global tables that allow you to have tables being duplicated and replicated across to another AWS region. And you can write in both of those and have data going and streaming in both ways. So if you're building global applications, DynamoDB is going to be a great way for you to build these capabilities out. The next one is Amazon DocumentDB. Now this is a MongoDB compatible engine, and it is built with the Apache 2.0 open source MongoDB 3.6 APIs. So essentially what we're doing is we are emulating those APIs and giving your application a response that it would expect from a MongoDB application. Now that means that your applications today, you can simply take them from pointing at MongoDB and point them to Amazon DocumentDB, and they will continue to work as they were previously. So it's a great flexibility to bring this into a managed service on AWS. As well as that, if you've used MongoDB and tried to scale it up, and then perhaps even scale it back down, you'll know that that process is quite trying. Now with Amazon DocumentDB, we can actually spin up read replicas up to 15 very simply, and then when you don't need them, you can actually turn them off again. So you're going to be able to get a much better service for you to scale up and scale down with Amazon DocumentDB than if you were running MongoDB yourself. And I think this is something that's a really big pain point for many MongoDB customers that I've talked to, so I'd highly recommend you start looking at Amazon DocumentDB. The next one we're going to talk about is Amazon Elasticash. So this offers two different engines, Memcached and Redis. So Memcached is pretty much a straightforward cache. You store strings, you put the data in, you get it out. It does allow you to actually scale across a number of different nodes, but fundamentally it is a pure cache. Whereas Redis is more of an in-memory DB. And what we're seeing is that most customers are adopting Redis these days. And some of the capabilities that it has include atomic operations, which are really important for things like counters to make sure that you're getting the actual increments that you want. And then pub/sub, which is quite complex and well implemented to allow people to use things like queues. And then there's ordered sets. Now, ordered sets are great for things like leaderboards. So if you've got a game and you want to see your top scores, then that can be already ordered in memory from the Redis database and just pulled out and displayed in your application. Or it could be something similar for, say, a news site where you want to see the top articles. Again, that's an ordered set that you're going to pull back and bring that into your application. So this is really good. We do see caching being used as kind of its own data store now, especially for things like session management and even for more complex use cases. But one of the other use cases we see is protection of a relational database. And that means that you can put in memory cache in front of your relational database, get a lot of the reads from that, and protect your relational database behind that so that you don't have to scale that relational database as much. Now this is really good because if you think of things like an e-commerce site where you've got product catalog, that's mostly read-only. It's going to be served much faster to your customers. So not only are you protecting your relational database, but you're improving the user experience as well. The next one is Amazon Neptune. Now this is a graph database. The easiest way to probably think about graphs is if you think of Facebook and what they refer to as the social graph, you can think of you and then your friends and their friends, and there's quite a few different relationships between all the interdependencies of that, let alone the posts that you're posting and the interactions on those posts and comments and the likes and so on. Now, that is a quite complex graph, but there's other graphs out there for looking at analysis of things like purchasing patterns and then giving recommendations, so a recommendation engine. Also looking at things like fraud. So perhaps if you're looking at a bank situation for credit card applications and you want to detect people who are submitting similar addresses or similar personal identifiable information across different applications, then graph databases are very good for these types of use cases, as well as things like knowledge graphs. So what we see here that Amazon Neptune is able to query billions of these different relationships and give you that very fast compared to a relational system. And again, this is a fully managed service using open source and open standards. So we've got Tinkerpop and W3C RDF as the graph models, if you like. And then the languages that you're going to be querying with are Gremlin and Sparkle. The next one is Amazon Timestream. Now, time is really difficult to manage in a relational database. You can do it, but you're not going to get the kind of performance and the operations that you can do if you have a purpose-built database for time. So think of some of the use cases here, manufacturing plant or a oil refinery, where you have things like, say, temperature sensors and pressure sensors. The constant that you're analyzing against is time, and then the variations are the temperature readings and the pressure readings. And you might have requirements for hot data to analyze, is the temperature sensor going out of range, and reporting on that very quickly. But you also might want to look at things over a longer period of time and compare things and look for anomalies. Now, anomalies in these types of environments where pressure and temperature is getting out of whack might be a sign that things like maintenance need to be done to prevent failures going on. So a lot of this is much easier to do when the whole design of that database is around time. And that's what Amazon Timestream is all about. It's available in preview today, and hopefully later this year, it'll be generally available for you to use in production. The next database is Amazon Quantum Ledger Database, otherwise known as QLDB. Now, a ledger, you can think of that just like your bank statement where you've got your credits, your debits, and your balance. And you hope that that is immutable. If you could prove it, that would be great, because then you could have no argument with the bank about the transactions that are coming in, and they would know definitely that this has not been changed. And you hope that is what is happening. With QLDB, you are able to do that. You're able to have an immutable, cryptographically verifiable journal and ledger. Now, what this allows you to do is some pretty interesting use cases. Obviously, the financial ones are there for similar like a bank statement. It could be a government grant system where you're giving out grants and you want to be able to track and record all of those details. But it could be also something like vehicle registration details and managing the ownership of that vehicle over time, making sure that nobody can change those records. And then another example, which BMW is doing, is they're recording all of the maintenance records of their vehicles, so the second-hand owner can see all of the records and prove that that has been the maintenance done on that particular vehicle. And the last one we're going to talk about today is Amazon Managed Apache Cassandra Service. So if you are in love with open source technologies and you love your Cassandra database and you don't want to use some of the other databases at AWS, then by all means use this service to implement your Cassandra databases. Now, this is supporting the Cassandra query language. So again, similar to what we were talking about with Amazon DocumentDB, the way that you can use this service is just point your existing applications at it, and we have implemented the APIs and will give you the responses that you expect. So this is going to allow you in a serverless model to scale your Cassandra databases and make managing that in AWS very easy. So looking at our approach, remember we talked about that application technologies and architectures are changing, that customers are moving from monolithic technologies into microservices. And when they're in that microservices environment, for each of those microservices, they get the freedom to choose the different technologies for the languages they want to write in, as well as the databases or data stores that they want to use. And to help you in that environment make those choices for the right database, then AWS has a series of managed services that we've been through, whether it's for relational model, which is still a great way to start if you're familiar with that, or with NoSQL models, or things like document models, as well as graph and ledger, as we just saw. Now, all of these are managed services, and it's really important to understand the benefit of this. You don't have to worry about having to provision physical hardware. You don't have to worry about installing the software, patching the software, doing upgrades, and then things like backups are taken care of for you, as well as recovery in event of a hardware failure, storage failure, and so on. So we want you to concentrate on doing what you do best, which is building the applications that delight your customers, and let us take care of managing the infrastructure and the databases behind the scenes. Now, if you do need to get data into AWS, so let's say you've got databases that are either on premises or even on EC2, then we do have two technologies to help you with that. The first one is the database migration service, and this is all about moving data from one database to another. So you can bring a Postgres database into Aurora Postgres with the database migration service with minimal downtime. But you could also bring an Oracle database and then point that at another relational database such as MySQL, for example. Or you could bring a NoSQL database in, such as MongoDB, and then bring that into DocumentDB. So the database migration service is going to allow you to move between different types of databases with minimal downtime from on-prem EC2 and into our managed services. Then there is the schema conversion tool. Now, if you need to move things like, let's say you're migrating SQL Server, but you'd like to move that to Postgres, but you need to transfer the schema definitions, the table definitions, the data types, as well as T-SQL, and convert that to PG-SQL, then all of that happens within the schema conversion tool. Now, it's not going to be fully automatic. You're still going to have to do some manual work, but it is a great way to get started and make that process much easier. So if you do want to get started, then we have a couple of links here. The first one is aws.amazon.com/databases, and that's going to give you a whole heap of information to show our documentation, our get started guides, our videos, and all sorts of things to help you get up and going. Now, if you do want training and certification, then there is self-paced learning that you can do online. There is in-class options as well for specific areas that you want to learn about AWS. And there is now a certification course for databases. So whereas before you might have done your solution architect certification, now you can do your database certification as well. So that brings me to the end of my session. Thank you very much for attending the AWS Summit Online, and please fill in the feedback form. Thank you very much.